we funded this proposal from the University of Virgin Islands, and the proposal had two objectives. The first objective was to create a blockchain-based proof of concept for the farming co-op community. And the second objective was to train HBCU students in blockchain development. We thought this was a very important step because this is the stage where students, if they know enough about blockchain, they can actually start creating projects around blockchain. So one, of course, is the use of the case use. So how can blockchain be used? And second is to develop the proof of concepts for blockchain. So we used a team approach for this because there are so many different components to achieve an objective like this. And our team members are present out here. Sean Francis is from the University of the Virgin Islands. Max Bushov from Morgan State University, and Tom Cooksey from Simba Chain. The three of us worked together as a team to get to this stage. I will serve as the moderator of this panel. If you have any questions, please put those questions in the Q&A, and those questions will be relayed to us so that we can answer those questions. Once again, the key objective behind today's session is for HBCU community to let's use this opportunity to see what's possible for you all to start creating similar solutions in your campus. So this is on the innovation side, entrepreneurship side, etc. So let's go to Sean.
All right. Thank you, Dr. Wapner. So, as said before, this project was initially conceptualized by the group, the Emerald Archipelago Group, at the University of Virgin Islands, led by Dr. Joanne Luciano, back in June of 2020, after being awarded a grant from the FinTech Center of Morgan State University. Since then, it has scaled and continued into an incredible collaborative project between MSU and Simba Chain, with fellow researcher Travis Hamlin inheriting and carrying the torch forward. Now, to give a little bit of background information, the US Virgin Islands consists of 4 islands: the mountainous St. John and St. Thomas Islands, measuring about 19 square miles and 32 square miles, respectively. And then we also have the rural and relatively significantly larger St. Croix, measuring at 82 square miles. These relative. And lastly, within swimming distance of the southern coast of St. Thomas is Water Island, which is just 1 square mile large or less. And as of the 2021 census, the population is currently at 87,146 persons. Now, with this background established, here's a problem the project has identified and seeks to rectify: food security. Currently, the territory imports a whopping 97% of its produce. Because of this extreme overdependence, produce inherently has far less nutritious than it should be, as shipments take weeks to reach the territory, where the distance from Miami, Florida to USVI is about 1106 miles. In those weeks of transit, produce nutritional value depletes. Even more importantly, the territory is incredibly susceptible to supply chain issues. In 2017, the territory was devastated by 2 Category 5 hurricanes, Irma and Maria, and left the territory dependent on FEMA and the goodwill of royal citizens who heard our pleas. And as I bored you before with the land masses from each of the islands, there are a number of spatial and land constraints affecting agriculture in the VI, namely the terrain, where St. Thomas and St. John are mountainous and offer minimal acres for farming, and there's also federal constraints, but 2/3 of St. John are designated as national park, further reducing the available land for farming. Now, pictured here is St. Thomas's Farmers Market at Market Square. One of the few points produce is aggregated and sold weekly on St. Thomas. Within our culture, buying local produce is not the norm, which means these venues are incredibly limited in stock inventory. Very few farmers are capable of servicing grocers and restaurants. In addition, there's zero coordination between the local market outlets on the island, which means the idea of farmers collaborating to grow produce to meet the demands of restaurants or grocers, unheard of. Which brings us to our overall goal. We aim to design and launch an infrastructure to facilitate and foster the growth of the local agricultural economy to serve grocers and the restaurant industry. And our secret spice of life, blockchain technology. We intend to capitalize on the transparency aspect to give farmers a clear data-driven analysis of the distribution of produce available for sale, and also aggregate farmers' produce into bundle up into orders in a fair and distributed manner. With this intended impact, we aim to achieve an increased demand for locally grown produce, which would present an opportunity for farmers to invest in themselves to optimize their farming capacity to service the demand, which would overall lead to a healthier community. In addition, the infrastructure will be integrated with the aggregation network to meet the needs of even larger buyers.
Thank you, Sean. After the goals were realized, we moved to the application development process, and pretty much the process can be divided on two big parts or two big stages. Process design, which is not directly connected to blockchain, and smart contract development, which is directly related to blockchain. So let's talk about these two stages. Next slide, please. First of all, we started with process description and process flowchart. Process description was just a Word document, which included a brief description of the process as a text, maybe with some bullet points. In addition to that, process description included information about participants of the process, buyers, sellers, and so on. And it included information or parameters we would like to know about these participants. For example, we would like to know name of the company, address, phone number. If we are talking about certain documents, also there is a list of documents was included in the process description, document number, and so on. So all this information became our starting point, and based on that, we created a process flowchart. It's probably hard to read from here, but I will highlight the main elements of this flowchart. First of all, you can see there are three participants here: seller, buyer, and aggregator. Well, sellers are obviously agricultural companies or farmers. Buyers might be restaurants or grocery stores. And by aggregator here, we mean blockchain. So it's not a person, it's a code, it's blockchain. Also, it's important to mention right in the beginning that you can see that buyers and sellers do not communicate directly. All communication goes through blockchain. So blockchain receives information from one side and translates it to the other side. So how the process works, again, briefly, without going into much of the details. The process initiated by the buyer. Buyer have an option to either choose the products available in the availability list. Availability list is a list of products offered by all sellers, by all farmers. Otherwise, buyer can create purchase request and post it on blockchain such that sellers will be able to review the request and satisfy it if they can and want. Based on that, we are creating purchase order and sales order. Obviously, this sales order should be approved or signed by both sides, sellers and buyers, as a seller and a buyer. After the After the document, the sales order is signed by both sides, approved by both sides. We are going to delivery process itself pretty much. Seller should prepare the product and ship it to the buyer. Also, notification goes to the buyer that the product was shipped. Buyer confirms receiving the product. Again, everything goes through blockchain. Seller creates or prepare invoice. It's sent to the buyer. Buyer pays invoice, and that's pretty much ends of the process. Next slide, please. Based on the flow chart, we also created Wireframe. Wireframe is just a foundation of a graphical interface of the application that should be used by buyers and sellers, by participants. It shows what information, what screens will be available in this application with graphical interface and the relationship between them. You can see some rows in the wireframe. In general, wireframe pretty much repeats the information in flowchart. If you will compare them, you will see a lot of similarity. It's almost this. It's just two different angles on the same situation. Next slide, please. And that concluded the first step, process design step, where we were working on the process without focusing on blockchain. So technically, the same thing might be, or at least in theory, implemented without blockchain. But we realized that the blockchain approach will be blockchain solution will be the best approach for us. So that in this step, so as the next step, we moved to smart contracts design and development of smart contracts. Here we used the Simba chain solution, which helped us a lot. A few words about Simba chain. It offers design. Smart contract design into, we can design smart contract in two modes: a graphical mode, the one you can see right here on the slides, and a code mode. Code mode is a good idea for those who have pretty good coding skills. But if you are not a coder, if you are not familiar with programming, graphical mode is probably a solution for you. And that's a starting point in creating smart contract. Here you can see what we did. We created, they called assets, red rectangles, participants, and products. And we created documents that should be created or should be used during the process. That includes invoice, pay and slip, purchase request, availability list, and purchase sales order. And generally speaking, we connected all these assets together, which built a foundation for smart contract. So the good thing about this approach is that you don't need any coding skills to do that. After that, you can move to the coding mode and start to build logic. How smart contracts will really work. And this step, I will pass it to Tom.
Great, thanks, Maxim. So what I'd like to do is I'd like to go ahead and share my screen if I can. So if you would, go ahead and do that. And so let's see, hopefully everybody is seeing my screen, yeah? Okay, so what I'd like to show you today is this is what's called our smart contract designer. And before I actually get into kind of displaying that logic that Maxim was just talking about, how he was able to structure that logic up and use this tool to do that, one of the things that I want to kind of highlight on that that Dr. Bopna talked about at the beginning of the talk is that, you know, many times as a learner, we'll hear something and we just forget about it. You know, if we see it, then maybe we remember it. But if we can get our hands dirty, if we can start to use tools to kind of see how things are working, it has the ability to allow us to kind of really have a full understanding of it, right? And we call it taste it learning, or maybe it's the Piaget method. It just depends on, you know, where you learn that. But generally speaking, what we want to do is we want to be able to give people the ability to understand what's happening. And so with that on this tool here, we have basically our smart contract designer, which in essence defines the logic of your workflows. And the important thing to remember about a blockchain is that a blockchain is going to give you the ability to have that immutable ledger that you couldn't do with, you know, like dual entry accounting, right? So we have triple entry accounting that gives us that level of hardness to our data. And so when that data has multiple actors that have to report on it, then it's important that we have some type of visibility between those actors. And that's where blockchain really becomes helpful within a supply chain architecture. And that's what we're trying to do here, is we're trying to track these products through the packing slips and that type of thing. And so I'm going to open up this particular one. I'm sorry, I opened up the wrong one there. But this is that particular smart contract. And so when we look at what do we consider assets, we consider the products an asset. And when we're defining these products, as Maxim mentioned, as an input of an asset on a ledger that we're keeping track of some value, because that's an asset, then we have to define what we call the tuples, right, or the key value pairs. And this is just you know, a label of what we're keeping track of, right? So I'm keeping track of the ID number, the name, the type, its description. And then over here, this is what we call a data primitive, right? And so a data primitive is really simple, but if you have any kind of background in like data design, what we're trying to do is we're trying to do what we call data minimization. We're trying to take up as least amount of space that we need in order to represent whatever is needed by that data set. So for instance, a Boolean is a really easy way to represent something, and I can do it real simple with a real small amount of space, because all it has to have is a switch that's either on or off, right? It's either positive or negative. It's a 1 or a 0. I don't need to take up a lot of space on my computer in order to be able to store that. But when I think of something like a string, for instance, a string could be any combination of characters, and it could be any length. And so that sometimes takes up a little bit more space. When we look at an integer, I'm going to come back to address, and I'll talk about it in a second. An integer is really going to have something that we would either be doing some math on, and usually that's going to be just a standard int. Because a lot of times when we're doing math on something, it can have a negative value. And if something needs to be able to be represented in negative context, then it needs to be an integer or a signed integer. An unsigned integer means that it can't go negative. It's just going to have positive values and kind of zeros the floor. So sometimes, you know, in workflows, that's the case. You know, it's going to be a number, but it's not going to be a negative number. Like if it's a number for a street or something, then that's not going to be a negative number. Sometimes we'll just put that in as a string. But in any event, that's what this does. It allows us to define those, right? If it's a byte, well, all a byte is a byte is where it's represented to the computer in a certain way, but it has to get translated into like ASCII before it can be read by us as a human. So byte is just a really it's kind of like a primitive way for the computers to talk to one another. And so we can see how big these sizes are for this communication. So what we're doing is we're just simply defining what's going to be important. Now I know that I kind of went through that a little bit in depth there, but if you think about this and you kind of think about what Maxim and what Sean were talking about, what are we trying to do? We're trying to capture data points that are going to have value in this workflow. Data points that represent the asset, data points that represent the asset's life cycle, right? And as that life cycle changes, we need to capture those measurements. Maybe it's the temperature of an eggplant, or maybe it's how long coconut water has been sitting on the back of a truck, right? So those are going to be measurements that are going to be really important for us to be able to understand kind of what the goods usage is and its capabilities. So with these workflows here, we can quickly come in and just quickly make an iteration and say, hey, I don't need to know the expected crop data anymore. I need to know the harvest date. And so we can just change that, right? So here's the beauty about this tool is, as you can see, it's as simple as coming here and adding an asset or a transaction. And when I do that, I just name it, I put in the parameters, and I just build it. But like Maxim was saying, is in the back end, we kind of have this what you see is what you get thing happening. It's not complex structure, right? So if you're a coder, this isn't going to be very impressive to you. But what it does do is it does allow us to define that input architecture of what that smart contract should look like, and what data points that we want to keep track of and put on chain, so that we have visibility and track and traceability on that part of our workflow, right? And when we think of a blockchain, you can kind of think of a blockchain as like this amazing index system. I say, where do we used to go for the data? We would go to the library. And where would we go to get the data in the library? Well, we would go to the Dewey Decimal System. That's kind of what the blockchain is. It's the Dewey Decimal System for data that we want to go pull up somewhere. And so what we're doing is we're just kind of creating that concept here. So we've built this workflow out, we've generated it, and then usually the next thing you want to do is you want to see it, right? You want to see, how does this work? I want to do an iteration on it. If it doesn't work, then in the industry we'll say fail fast, right? We'll say that it's kind of the Edison method, if you will, but it's our ability to check to see if something works. If it doesn't work, then let's try something different, right? How many times did Edison try different elements before he got to tungsten when he was making the light bulb? That kind of thing. And that's what we're trying to do. We're trying to figure out what data points is going to be important for us, and we're allowing who to build this out? Not the developer, right? This is the business professional that has the ability to come in here and define these data points. It's an easy to use tool, but it has power to give them the ability to unlock the ability to communicate and put the data points that they want onto a blockchain. So how do they do that? Well, after they've built out this smart contract and they've defined this code, then we can layer an application on top of it. And that's what we've done here. Is when we come in here, we can just click on the plus, and then we can go in and just define what platform we want to use. And what we try to take the approach to be platform agnostic. So if you're familiar with project management and the 3 Ps, we want to leverage the strength of our people, manage at the process level, and be platform agnostic, right? And that's kind of what we try to do at Simba, right? So we want to give you the tools to manage those workflow processes, and that's what this does. But here, this is all the different smart contract platforms that we support, and most of them are relatively agnostic. We try to write to what we call Solidity, which is the EVM compatible smart contracts, and as long as we do that, then that makes it so that this logic that you're creating, you can decide, well, I don't want to put that on a public chain. Maybe I want to put it on a private chain, and you can have more control over your workflows. So anyway, once you've decided on that, then you can go ahead and you just build this out. And then once that's built out, then you'll have like what we have here, this UVI demo. And you'll notice that I have a few things in here. I have my API keys and this thing here called the method call, my transaction logs, and then my app info. I'm really going to concentrate on my method call section here because I think it's going to give you guys the best idea of understanding what's happening. So I'm going to come in here and I'm just going to put in my password, and then we'll go out and take a look at the transaction log. But when I put in my password here to unlock what's called the wallet, whenever you're writing transactions to a blockchain, that costs. Whenever you're reading them, it's free. So we have to wallet if we're going to be writing transactions. So that's what we're going to have here. And so this is all of my setters, right? So this would be all of my setters to create a packing slip, to add products and purchase requests. But the nice thing about this one is it's just an easy to use tool that allows the end user to just go through quick iterations and see if something works. And so, for instance, if they wanted to come in and create a new product, then they could just come in and just put in the parameters for the new product, and then it would show up over here in their transaction log. And so let's go over here and let's take a look. Before we look at the transaction log, one last thing that I want to show you above the transaction log is we also have a location here that gives you the ability to manage what's called the API keys. So real quick is what we're generating is called a REST-based API. That's basically an endpoint, like you go to a certain place on the internet and it's got the little S at the end, right? Well, that's what we're doing. We're creating a secure HTTPS endpoint that you can go to in order to do getters and setters for the logic that you just created. And so that's what this does, is it allows you to hit that REST-based endpoint that you're generating to see if it kind of works. Like what Maxim said is we're wireframing this up, right? We're building out kind of the structure or the movie set, if you will, that sees if it's going to do what we want it to do. If it doesn't, then probably we don't want to put that extra effort in building the logic behind it. So here we're looking at those data points, right? And again, these are the metadata. Metadata is just data about data, but that metadata is what bundled together provides either utility or some provenance and state validation to the workflow. And that's why the blockchain gets so, it's so important. It's like receipts that are just digital, right? Now you have this digital scarcity functionality. And so if we go in and we actually look at one of these latest transactions here in our transaction log, and then in a second we'll see the kind of the finished product, what it would look like to the end user. And again, the important thing to remember here is we're building out the back end of this, right? But we're giving the functional user the tools that they need in order to kind of sculpt up what that back end should look like. Okay, so here, for instance, we have a product that we delivered, and let's look at this product. Well, this product was eggplants. Okay, well, here's its ID number. It was produce. And then we have kind of like the receipt that came from the blockchain that tells us what block is it in, the block number, and then it's got an ID for that block called the block hash. And all of this additional information that we're reporting on here within this app. But notice also we put a little link here, and this will actually take you out to what's called the Blockchain Explorer. Since this was published on, it's called the Binance blockchain. It's very similar to Ethereum. They have a public explorer, so you can actually go out there and look at that transaction. So 4 hours ago, I created the eggplants, right? And so here is the transaction was written to that smart contract. It came from my wallet, and you can see, here was the block number, and from and to, and here's all of the the transaction hash. And here I can expand that out, and this would be the actual. That was the raw data. There's my eggplants and my produce. So there it is. They're out on the public blockchain. So pretty cool. It's kind of a easy to use interface, but it's very, very powerful because it gives you the ability to kind of create and sculpture up what your intentions are. And many times what ends up happening is when we hand this off from the what we call the functional professionals, right? The ones that know the workflow better than anyone else, but they're not necessarily a developer, right? When they hand that off to the developer that they want them to build something, there's a lot lost. There's a lot of ambiguity lost, right? And so hopefully with tools like this, we can start to remove some of that ambiguity and start to ensure that the intentions are correct before we start to put in a lot of development effort. And what this will do is hopefully it'll give us better outcomes